How do ORMs work under the hood with SQL translation? Imagine you're working with objects in your code, like user profiles or product listings, but your database only understands tables and rows. How do these two worlds connect seamlessly? That's where Object-Relational Mapping, or ORM, comes into play. It acts as a translator between your code and the database, making data management much easier. At its core, an ORM creates a bridge by mapping classes in your code to database tables. Think of each class as a blueprint for a table, with attributes representing columns. When you create or update an object in your code, the ORM figures out how to turn that into a SQL command. This process is called SQL translation. When you ask the ORM to fetch data, it builds a SQL select statement based on your query. For example, if you want all users with a certain age, the ORM converts that into a select query with a where clause. Once the database runs the query, it returns raw data in rows. The ORM then takes these rows and turns them back into objects in your code, complete with properties and methods. Different patterns help ORMs do this job. The active record pattern makes each class responsible for its own database operations. So, a user class can save itself or delete itself directly. The data mapper pattern separates the object logic from the database logic, using a dedicated component to handle the translation. This makes the code more flexible and easier to maintain. Under the hood, the ORM dynamically generates SQL queries based on what you do with your objects. It uses method calls or query builders that look familiar to your programming language. This way, you don't have to write raw SQL, which can be tricky and error-prone. Instead, you work with simple, readable code. ORMs also handle relationships like one-to-one, one-to-many, or many-to-many. They generate join queries to connect related data and rebuild object graphs to reflect those relationships. They can control how related data loads, either fetching everything upfront or only when needed, to keep performance smooth. Some ORMs support schema migrations, allowing you to evolve your database structure over time through code. This keeps your database in sync with your application without manually changing tables. For backend developers working with APIs and databases, ORMs make data access straightforward. They let you work with objects instead of raw SQL, reducing boilerplate code and improving security by using parameterized queries. This speeds up development and keeps your code cleaner. In simple terms, ORMs translate object operations into SQL commands by mapping classes to tables, generating queries on the fly, executing them, and turning results back into objects. This process makes working with databases much more accessible and helps you focus on building your application rather than wrestling with SQL syntax.